All right, this is Unit 1, Topic 1, Lesson number 6. So we're getting into constructions using those compasses. It says, how many planes appear in this figure? This is one plane, just plane S. Name 3 points that are collinear. That means in a straight line. That would be points A, B, and D. That is actually the only choice in this diagram. Are points A, B, C, and D coplanar? No, they are not. B and C are coplanar. Point A is not on the same plane. It's above it. And point D is below it. So this is the way we draw diagrams like this. We're trying to draw a two-dimensional diagram to make it look like it's three-dimensional. So when you draw this dotted line here, it makes it look as if it's going through the plane. It's the part that you can't see like through the piece of paper, as I have described in other videos. Are points A, B, C, and... Oh, no. Sorry, I just answered that. At what point is line DB and CA intersect? CA and DB intersect at point A. Point A is where they intersect above the plane S. All right, so we are going to be doing constructions, as I just mentioned a second ago. And let me... All right, sorry for that pause. I had to get myself my compass. So I have my compass now, and I'm going to use my compass in order to construct arcs and circles and all sorts of other things in this case. We're going to construct different things using that compass, because I know it makes an arc or a circle, but you can use it to make other things as well. So we're going to start off with constructing copies of segments and angles. And we're going to start off with copying a segment. And these are just literally instructions, but I'm going to show you how to do it. So honestly, I'm just going to skip that. So the first thing you're going to want to do is give yourself a straight line. So once again, like I said, what I'm trying to do is I'm not trying to construct or make a copy of this segment. So segment DC is right here. And I want an exact copy, meaning exactly the same length, right? And so I'm going to call this point D. So all I did was make a straight line using a straight edge, which you would use like a ruler. And now what I'm going to do is I'm going to use my compass. I'm going to put my what's called a fixed point on one side, not the pencil point, but the fixed point, which stays fixed. It doesn't move. You hold that one steady. And then I'm going to close my compass so that my pencil is at point C. All right, and I want it to be precise as possible. All right, so that's not what I intended. All right, so a little bit more. Okay, there we go. And then what I'm going to do is I'm going to make an arc. I'm going to rock it back, holding the fixed point steady at point D. I'm going to rock it back and forth so that it makes an arc going through point C. And then I'm going to put it over here where my copy of point D is, and I'm going to make the exact same arc. By doing this, I'm literally just measuring it without using a ruler. Now, yes, I could do this with just a ruler and measure it with the side of a ruler, but that's not the point. The whole point of this is to use a tool which proves congruency. It's all about proving by making things that are exactly the same. We're going to get a lot more advanced in these constructions later on. Last thing I need to do is label these, the fact that they are the same, and this is right here. I need another point. This is point C. Now, I'm going to put little marks, and these are called prime marks. These prime marks are exactly the same as DC. So segment DC and D prime C prime are the exact same thing. I know in higher level maths, like in calculus, you'll call this dash. All right, number 2, we have segment GH. Now, I'm going to do the exact same thing. I'm going to start off with a line, and let me try to thin this line out a lot. I don't need it quite so thick. I'm going to start with an endpoint on it, and I'm going to call this point G. Doesn't really matter which one I use. I'm going to put my fixed point on G. I'm going to make it so the compass has my pencil, so I might have to close it up a little bit. My pencil is on H, and then I'm going to prove that I'm going through the point. Now, I missed it by just a smidgen, so I'm just going to make it a little bit smaller and go through it again. I think I'm a little bit happier with it now. I guess I probably could go a little bit smaller again. There we go. So the whole point is I want to make sure I get it exactly precise. I'm going to go over here, put my fixed point on G, and then I'm going to make the exact same size arc so that it intersects the line that I made originally. Now, I know I made this line really long, and I don't need it to be that size, but I made it really long on purpose, making it longer than I need, just to make sure that I wouldn't have to extend it some more. And this is going to be point H, and this segment is now the same size as this segment. Now, I know some of you are wanting to get rid of and use your eraser and delete this part of the segment. Don't need to do that. In fact, I actually prefer that you don't do that. This notation here proves that we're just looking at this section, right? And the reason I have you leave this here is because it proves that you went through the process of construction. And if you don't have that, then honestly, it looks kind of like you just guessed. All right, number 3. So one more. Let's first start with our line. It really doesn't matter what direction. We're just making a copy. They don't have to be in the same direction. So let's call this point Y. I'm going to put my fixed point on Y, and I'm going to open my pencil up to point Z, or as close as I can get it. Make an arc, rock it back and forth, holding the fixed point firmly on the point. I'm going to do the same thing here, and I'm going to make the exact same size arc. Now, I made this one a little bit longer. That doesn't really matter, because all you really need is that point of intersection. You can make this arc a little bit smaller if you want. But point Z, and we're going to call this Z prime, and this is Y prime, so G prime and H prime. So the prime symbol just means that it's the copy of the original, just so that you know. All right, so now we've done segments. Now let's go to angles. So how do we copy an angle? Now, these are some instructions, but honestly, I'm just going to go straight to showing you how to do it. Everything I do here is done on purpose, and it's done for a reason, and it's good for you to know what that reason is. So I'll try to do my best to explain it as I'm doing it. Now, the first thing I'm going to do is I'm going to start off with a ray. And this ray is going to have an endpoint, obviously, and that endpoint is going to be my vertex. So this is going to be my E prime, right? And I'm going to try to copy this angle right here. So by the end, it's going to look something like this. But if you do that, you're going to get no credit because it clearly looks like you just guessed. And the whole point of geometry, and this is, I know this is one of the first things that we do, but the whole point of this activity is to get the understand of how to prove things, how to prove that it's an exact copy. So what I'm going to do is put my fixed point on E. I'm going to open up I can open this up as much as I want. It really doesn't matter as long as it's going to intersect both of the rays, which it does. Okay? And then I'm going to bring this fixed point over here to E prime, the exact same point, and I'm going to make the exact same arc. Now, sometimes teachers have you make a full circle. You don't need that full circle, but at the beginning, maybe that's going to be more helpful for you. You see how long this arc is? I would make the arc longer. It always helps to make it longer than the original when you're making the copy because you don't want to have to go back and redo it. So always give yourself more of an arc than you had originally. The whole point is we need this arc right here. We need to know where this point of intersection is. So what I'm going to do now is I'm going to literally measure from intersection to intersection, because right now we only have one point of intersection. So everything's got to be a copy. So we know this arc and this arc are exactly the same. What we need is another point on this arc that is the same distance. I know it's curved. It's a curved line. It's called an arc. But we need it to be the exact same distance for both. Now, before I do this, I need to close this up a little bit because clearly it's not going to fit on the screen. All right, let me turn this and notice what I'm doing here. I'm putting the fixed point on one point of intersection. And sometimes it's helpful to give these points of intersection a name. I'm going to call this F and call this G. I'm going to put my fixed point on F. I'm going to put my pencil on G, and I'm going to make an arc. Now, it's a copy. Everything has to be exactly the same. So this is F prime because it's on the original ray. The ray is a copy of this ray. I'm going to put my fixed point on F prime, and I'm going to make an arc so that it intersects my first arc. And this is the point that we need. That's point G, because this and this are the same distance. So we know the angle is the exact same amount. And that's what an angle is. It's about the direction of the rays. I know we're measuring this distance, but it's really about the direction. And then I'm going to connect using my straight edge, my vertex going through G. And there's my angle. Last thing I need to do is label the fact that these two angles are congruent. All right, so let's go through those steps one more time. Down here for number 2. So first we always start off with a ray. It really doesn't matter what direction it goes. I'm going to call this Q prime as a copy of Q. And then somewhere over here, all right, so I'm going to put my fixed point on Q. And then somewhere over here, I'm going to make an arc. So that gives me 2 points of intersection. Very important. Let's call this R and let's call this S. I'm going to bring my fixed point over to Q prime and do the exact same size arc. It's very important that you don't accidentally open up your compass. Everything needs to be done exactly the same when doing a copy. All right, so this point right here is going to be R prime because we know that this distance to here, based on the definition of a circle, if I use this compass to make a full circle, all of the points on the circle are the same distance as each other. So when I made the same circle here as I made here, now we have just proved that these two segments are the same. We've proven that. We've also, all right, so now what we're going to do is now I'm going to put my fixed point on R, put my pencil on S, and I'm going to make a second arc going through S. And this is going to help us find the location of S prime because the distance from R to S is going to be the same distance as R to S prime. Because once again, if I make another full circle, the radius of the circle should always be the same if it's the same circle. All right, so this is going to be now S prime, and then I'm pretty much done. All I have to do is use my straight edge, or my ruler, whatever you want to call it, to connect my vertex to my S prime, making an exact copy of angle Q. And there we go. And I put 2 marks because we have one paper, and I don't want to have 2 angles on the same paper with this that aren't the same angle to have the same amount of marks. And that's pretty much it. I know there might have been more examples in your packets. Actually, there wasn't. So that was it. All right. So thanks again for watching, and I will see you on the next video.